Assalamu alaikum students. How are you class 8? Fine, alhamdulillah. Okay, it's your maths lesson and today we'll first of all recall the laws of exponents and then we'll do some questions, okay? First of all, I am going to revise the laws of exponents. Laws of exponents. These are the very important laws and we will use all these laws while doing practice of our questions, okay? So the first law is, if the bases are same, what is this, boys and girls? Very good. This is exponent. And what is A? A is base. Good. It means you have learnt what I said yesterday. Good. So a raised to power m, a raised to power n, bases are same. What will you do? And they are multiplying. So you will add the exponents. Similarly, if bases are same and they are in the form of division, then what will you do? You will simply subtract the exponents. Good. The other third law which you will use in your questions is something raised to power 0 is equal to 1. And other important law which you will use in your question is a raised to power m raised to power n is equal to a raised to power mn. These are some laws of exponents. Now we'll solve the questions with the help of these laws. Okay? First question is, I am writing here a question. For example, if I have x raised to power minus 2, y raised to power minus 3, z raised to power minus 4, for example plus 4, over x raised to power 3 and y raised to power 2. This is a simple question having bases x, y, z with some negative and positive powers. First of all, we will identify which bases are same. Here we have two bases x and x. X raised to power minus 2 over x raised to power 3, which are dividing each other. Okay. Then y raised to power minus 3 over y raised to power 2. And then in the last we have z raised to power 4. G. Munib will tell me which rule will be applied to this base. Bases are same and we have two exponents minus 2 and 3 and they are in division form. Yes, Munib? Good. You will subtract the base exponent x as it is minus 2 and this exponent will subtract x raised to power minus 3. Similarly, again we have two bases with two different exponents and they are in division form, so we will subtract minus 3 minus 2. And in the last we have z raised to power 4. No base is same for z raised to power 4, so we will write it as it is. Now you will solve what is minus 2 and minus 3, x raised to power minus 2 minus 3. Minus minus plus, 3 plus 2 is 5, x raised to power minus 5. Similarly, y raised to power minus 3 minus 2 is minus 5 and z raised to power 4. Are we done? Is there any other further step? Yes, exactly. We will take reciprocal of the negative exponents. We will take the reciprocal of the bases having negative exponents, which is another law of exponent. So what will we do? 1 over x raised to power 5, 1 over y raised to power 5. These are the reciprocals of these two and z raised to power 4 will remain as it is. And the final answer is z raised to power 4 over x raised to power 5 y raised to power 5. This is your final answer. Is it okay? Next, see another example. If we have, for example, x raised to power minus 1, y raised to power minus 4, z raised to power 0 over x raised to power minus 2 and y raised to power 3, z raised to power 5, but with the negative power of minus 3 whole. What will you do now? First of all, let me write another exponent, x raised to power minus 3, for example, g. Here we have, first of all, first step is to identify the same bases. Okay? So, we have three same bases, x raised to power minus 3, x raised to power minus 1 and x raised to power 2. Next, we have two same bases for y raised to power minus 4 over y raised to power 3. In the last we have z raised to power 0 over z raised to power 5. Yes, what will be the next step, girls? Next step is to simplify the bases according to the laws of exponent. Here we have two same bases, x raised to power minus 3 with exponent x raised to power minus 1, and they are in the form of multiplication. So what will we do? We will add plus, and here we have minus 1, so I will write it in the form of bracket. Minus 3 plus minus 1 over x raised to power 2. Here we have two bases with negative and with two different exponents, but they are in division form. So we'll subtract the bases. Yes, exactly. Minus 4 minus 3. What is z raised to power 0? Will we do like this? Z raised to power 0 minus 5? Or is there any rule to simplify something raised to power 0? Exactly. Something raised to power 0 is equal to 1. Very good. So, we will not write z raised to power 0 over z raised to power 5. We will write z raised to power 0 is 1. 1 over z raised to power 5. Is that clear? Okay. Next step will be simplify the bases. Next step is to simplify the bases. So let's simplify. X raised to power minus 3 minus 1 is minus 4 over x raised to power 2, y raised to power minus 7 and z raised to power 1 over z raised to power 5. What will be the next step? Next step is to again simplify these two bases which are same with different exponents. So we will minus 4 minus 2 y raised to power minus 7 dot 1 over z raised to power 5. Minus 4 minus 2 is minus 6 y raised to power minus 7 over z raised to power 5. Is this the last step? No. So what will be the last step? Who will tell me? See this and tell me. Good. We will take the reciprocal. So when we take reciprocal, this minus 6 will change into positive 6. This minus 7 will change into positive 7. And this z raised to power 5 will remain same. Sorry, we have raised to power minus 3 also. Minus 3. Okay. So after taking, before taking reciprocal, there will be one more step. Multiply this minus 3 with each exponent. X raised to power minus 6 multiply minus 3. Y raised to power minus 7 multiply minus 3. And Z raised to power 5 multiply minus 3. Okay. As there is a whole power of minus 3, so we will multiply each variable, each base with this power. X raised to power minus 6 minus 3 is x raised to power 18. Y raised to power minus 7 minus 3 is y raised to power 21 over Z raised to power 5 multiply minus 3 is minus 15. Now 18 and 21 are the basis, are the exponents of x and y, but they are in positive. So we will simply take the reciprocal of this x raised to power minus 15. And when we take reciprocal, this will become x raised to power 18, y raised to power 21, and x raised to power, z raised to power 15. This will be our final answer. First step is to identify the variables having same basis. Then second step is to apply the laws of exponents according to the bases and exponents and in which operation they are. And then third step is by using the laws of exponents simplify each and every base individually. Okay. Now we'll solve some questions having numbers. These are the questions having variables. Now I'll solve some questions numbers involving exponents. Okay. Let's see. I have a question 2 raised to power 1 by 3. This is a question 2 raised to power 1 by 3 multiply 27 raised to power 1 by 3 multiply 60 raised to power 1 by 2 over 180 raised to power 1 by 2 multiply 4 raised to power minus 1 by 3 multiply 9 raised to power 1 by 4. This is a question and you can see all our numbers having some exponents. When we have numbers having some exponents, first step is to take LCM, to convert all the numbers into prime factors. First of all, first step is to find out all the prime factors of each number. 2 is a prime number. What are prime numbers? Very good. Numbers having exactly 2 factors, the number 1 and the number itself. Great. You know what are prime numbers. So first of all, 2 is already a prime number. We will find out the LCM of 27. Help me to find out the prime factorization. Help me to find out to do the prime factorization of 27. First of all, we'll start always with the smallest number. Let's check with 2. 27 is an even number, is an odd number. So we can't divide with 2. Let's move to 3. 3 9 times 27. Again 3 times 9. And 3 1 times 3. So the exponential form of 27 is 3 raised to power 3. Next number is 60. So find out the prime factorization of 60. Start with 2. 60 is a even number, so we can easily divide it by 2. 230 times 60. Again we have 30, which is even number, so 215 times 30. 15 is not a even number, so we'll move to 3. 15 is divisible by 3. 3 5 times 15 and 5 1 times 5. Next, factorization of 180. 180 is an even number. So simply 2 9 times 18 and 0. Again 90 is an even number. 245 times 90. Now 45 is not an even number, so we will try another 3. 3 1 times 3 and 3 5 times 15. Again 3 5 times 15 and 5 1 times 5. So this is the factorization of 180. Next number is 4. Take the LCM of number 4. 2 2 times 4 and 2 1 times 2. The last is 9. The LCM of 9 is 3 3 times 9 and 3 1 times 3. These are all the prime factorizations of number 180, 27, 60, 4 and 9. Okay. Your first step will be find out the prime factors, and now I will put all the prime factors. I will write the index notation. Do you know what is index notation? Exactly, writing the factors in exponential form. Good. This is 2 raised to power 1 by 3. 27. What will be the index form of 27? Here we have 3, 1 times 3 multiply 3 multiply 3. So we will write 3 raised to power 3 1 by 3 multiply 60. Prime factorization of 60 is, you can see 2 square multiply 3 multiply 5. 2 square multiply 3 multiply 5 raised to power 1 by 2. Now 180, the exponential form, the index form of 180 is 2 square multiply 3 square multiplied by 5 raised to power 1 by 2. Prime factorization of 4 is 2 square. So we will write 2 square minus 1 by 3. Prime factorization of 9 is 3 square. 3 square 1 by 4. Is that clear? Next step is to apply each power, multiply and apply each power according to the given condition. We have 2 raised to power 1 by 3 multiply 3 raised to power 3 multiply 1 by 3 multiply 2 raised to power 2 multiply 1 by 2. Here we have 1, here we have 1, and this 1 by 2 will apply to each base individually. 2 raised to power 2 multiply 1 by 2 multiply 3 raised to power 1 multiply 1 by 2 multiply 5 raised to power 1 multiply 1 by 2. Similarly, this 1 by 2 power will apply to each base. 2 raised to power 2 multiply 1 by 2 multiply 3 raised to power 2 multiply 1 by 2 multiply 5 raised to power 1 by 2 multiply 2 raised to power 2 multiply minus 1 by 3 and 3 raised to power 2 multiply 1 by 4. I applied all the bases according to the conditions. Next step is to simplify. Now let's simplify 2 raised to power 1 by 3 multiply. This will cancel. Multiply 3 multiply 2 multiply 3 raised to power 1 by 2 multiply 5 raised to power 1 by 2. In denominator, this will cancel. 2 multiply 3 multiply 5 raised to power 1 by 2 multiply 2 raised to power minus 2 by 3 and 3 raised to power 2 1 times 2 to 2 times 4. 3 raised to power 1 by 2. Is this step is clear? I applied the law of exponent. I applied each power to each base and then simplified. Now they are almost, most of the numbers are in its simplified form. I can simplify, 3 will cancel, 2 will cancel, 5 raised to power 5 1 by 2 will cancel, 3 raised to power 1 by 2 will also cancel, and I have only left with two numbers, 2 1 by 3 and 2 raised to power minus 2 by 3. Now look at this and identify which law will be applied to this. We have two same bases with different exponents and they are in division form. So we will subtract these bases, minus 2 by 3. Okay? And this will equal to 3, 1 by 3 plus 2 by 3. The denominators are same, so we will simply add 2 raised to power 3 by 3. After simplification, I will cancel this 2 raised to power 1 which is equal to 2. So you can see how complicated is the question and the answer is simple too. So first step is to write the factorization, prime factorization, do prime factorization and write the prime factors of each number and then apply each part accordingly, simplify, and then in the last you have to apply some law of exponent and then you will simplify your question. Okay? Watch this video carefully students, and I am uploading some questions for practice. You have to do practice of these questions also. Thank you students. Allah Hafiz. Take care.